So this isn't a lecture, this is just some notes for some hints for the exercises and a bit of chapter summary as well. Okay, so what have we got here? So x set 1, 2, 3, 4, a function from 1, 2, 3, 4 to the real numbers defined by this. Represent this using arrow diagrams. So what you're going to do is do f first, then g. So f goes from x to the real numbers. And then you're going to do g, which goes from the real numbers to the real numbers. Now if you want, you can do that, and then after that do g after. So either do a chain or calculate what 1 is sent to, 2 is sent to, 3 is sent to, 4 is sent to, and then just do a single arrow diagram. I haven't done that in the notes, but it's certainly an option. Similar story here. Look, label all sets. Yeah, so f after g. So you're talking, you can do two options, similar question. So these are relations. Is it a function? So remember, to be a function, every output, every input, so these are the things in the set A, has a unique output. Well, maybe I shouldn't say unique, it says has one output. That's probably a much better way of saying it. So, okay, it can't have two outputs, it can't have no outputs. If it's not a function, just answer it and go on to the next one. You know what one-to-one means. You've seen this, you know, onto an invertible is the same as being one-to-one and onto. So one-to-one means that nothing is hit more than once, and onto is that everything is hit. By hit, it has an arrow hitting it. Consider this function graphically represented using an arrow diagram. Shouldn't be an issue. Draw the graph. I think there's axes on the next page. So when I say graph there, it means coordinate graph. Oh, there's no axis. I don't know what axis on the next page means there. I think, so we'll set it up. So the input set and the output set. So you can nearly draw the name of the set. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Do not join up the points on the graph. Is the function invertible? You can either, well, if you find out it is, okay, do write down the order pairs, say f inverse. Otherwise, explain why the function is not invertible. You can either use the arrow diagram or this. And yeah, so you can either analyze it as normal, one-to-one and onto, or you can draw the graph here and do some horizontal line tests. Okay, this should be fairly self-explanatory. Just means do f first and then g. I'll let this question. So what I would do here, I would maybe calculate each of them. Calculate f after f of 1. And does it send 1 to 2 and so on and so forth. Okay. So just see, like, so two functions will be equal if they agree on all inputs. Next question here. So here you want to decide this, maybe, so if they're equal, they'll kind of have the same formula. So what you could do is you could try, and your algebra might let you down here, try and calculate these. So this first one, f after g, you do f of 2n. What would that be equal to? And then for the second one, you could do f first, which is n plus 1, and do g of n plus 1. See what you get. And if these formulas are equal, then they're the same function. If they're not equal, what you should do is find an example of an input that's a whole number, positive or negative, that they disagree on. Okay. This should be okay. This should be okay. Oh, draw the arrow diagram. Draw the arrow diagram. And this one we probably can't actually do yet until you do the algebra. You can try them if you want. I'll just show you the first one, but realistically to do the algebra. So f, a g after f. So you calculate f of x is 2x, and then you apply g to that. So g is, you square the input. So g of f of x, g of 2x, is 2x squared. And this is where you need your algebra, which would be 4x squared. And now I think we're not doing all of the algebra, which we'll talk about next week. For invertibility, you're looking at horizontal line tests. Invertibility, so what I'm talking about here is horizontal line tests can tell you if a function is one-to-one and or onto, and to be so if it fails to be one-to-one, or if it fails to be onto, it's not invertible. That's all you're saying there. If it's one-to-one and onto, you'll say that it is invertible. It's bijective and invertible. Horizontal line test. 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 The floor function. This is the graph of it. Horizontal line test. Is it invertible? And then these harder questions. So I won't. This is a harder question. So like if it's an additional harder exercise. If you can't do it, I'm not too worried. But you can give it a bit of thought if you want to push yourself. Now, next thing here, I suppose, is it's open book assessment. So like this is when you're doing your third assessment, as this stuff is on. This is a great page to have open. So a function is a set of x times y. So ordered pairs x, y such that each element occurs in one and only one. That means every input has one output. The ordered pairs can be written as x f of x. Set is this is the domain, the codomain, and all the things that are hit is called the range. And the second thing is not so important. It's one-to-one if each element here is hit at most once. It's onto if everything is hit. One-to-one and onto is bijective, and it will also be invertible. Composition of functions is this thing. The identity is the do-nothing function. A bijective function has an inverse, and the inverse will undo the function. So just like if you do the function, then the inverse is the identity, which is doing nothing, and it works the other way around as well. The vertical line test you see if a curve is the graph of the function. And the horizontal line test is see if graph function is a one-to-one or onto. One-to-one means cuts, every horizontal line cuts the graph, cuts at most once, and onto cuts at least once. If it doesn't cut it, that indicates, if you go back at the horizontal line test, that's an output that's not hit. And if an output is not hit, it's not onto. And again, look back at it. If a vertical or a horizontal line hits the graph twice, then that's an output that's hit twice. So you got two inputs hitting the one output. It's not one-to-one. Okay.